Hello students, it's Mr. Brooks here. Today is day 3 of graphing rational functions, and today we are going to start talking about something called a slant or oblique asymptote. As a little review, you should have already learned how to calculate the vertical asymptote as well as the horizontal asymptote. So please work on example 1. Why don't you calculate the vertical asymptote, the horizontal asymptote, the whole, the x-intercept, and the y-intercept. You can pause the video to do that work. If you recall, there are two different points of discontinuity. One is the vertical asymptote, the other is the horizontal asymptote. Here, in this problem, we have f of x or y equals x squared over x minus 6. 6 makes the denominator 0, so that is what becomes our vertical asymptote. Vertical asymptote is a vertical line, so make sure you write it as x equals a number. In this case, it's 6. Horizontal asymptote. What you need to do is compare the degree of the numerator to the degree of the denominator. Degree is a function of the exponent of the variable. So in the numerator, the degree is 2. Denominator, the degree is 1. Since the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. To calculate a whole, you have to see if anything simplifies or crosses out in the numerator and denominator. In this case, nothing does. You cannot, and this is a common mistake that students make, you cannot cross out the square root of that x along with that x because there is no x in that term. So you can't do that. There's nothing you can simplify or cross out, which means there is no whole in this problem. As far as the x and y intercepts go, to calculate the x-intercept, you plug 0 in for y and solve for x, and you do the opposite for the y-intercept. Plug 0 in for x and solve for y. It turns out that both the x and y-intercepts are the same, happens to be the origin. The new concept for today, again, is something called a slant or oblique asymptote. To determine whether there is a slant asymptote, you compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is exactly one more than the degree of the denominator, then you do have a slant asymptote. Again, the degree of the numerator is 2, the degree of the denominator is 1, so there is a slant asymptote. In order to calculate the equation of the slant asymptote, you look at the denominator and you see whatever makes it 0. Since 6 makes the denominator 0, that is the number we are going to put in our half box. And then across the top line of the synthetic division, we are going to do 1, 0, 0. The way we came up with those numbers is we look at the numerator, x squared, the coefficient is 1, and then since there is no x term, we write it as a 0, and there is no constants or plain number, so we also write that as a 0. We leave some space for a few numbers, and we do our synthetic division. So you bring the 1 down, and then you multiply the 1 by the number in the half box. 1 times 6 is 6. Write that here. Add straight down. Multiply the 6 by the number in the half box to get 36. And we add straight down again. We have 1, 6, 36 below the line. Here is the meaning of those numbers. The number on the right we simply ignore. Moving 1 to the left, that is our constant or plain number. Moving 1 more to the left, that is our x term. So the meaning of this row is y equals x plus 6. And that is the equation of our slant or oblique asymptote. Now, if we were to graph all of this information, our vertical asymptote, x equals 6, is here. We draw all asymptotes with a broken line. Don't forget the arrowheads. The x and y intercepts are the origin, so that is a point. There is no horizontal asymptote. There are no holes. The other line we need to draw is the line y equals x plus 6. So that is an y-intercept of 6, and the slope is 1. So there is our slant or oblique asymptote. In order to graph the branches of this equation, it would probably be a good idea to plug this equation into your calculator so you get a general sense of what the graph looks like. After you graph it, you should also take a look at the table so that hopefully you can find coordinates with integers so that it's easier to graph on the Cartesian plane. So it turns out one branch is here, and the other branch is down here. What you can also do is graph the slant asymptote as well, and you'll see the asymptote hugs the branches of the graph fairly nicely. We are now going to work on a few problems together. So let's take a look at example 2. F of x or y equals x cubed minus 5x plus 6 over x squared minus x minus 6. The directions tell us to calculate only the equations of the slant asymptote. So again, the rule whether an equation does indeed have a slant asymptote, you compare the degree of the numerator. You compare the degree of the numerator to the degree of the denominator. Since the degree of the numerator is exactly one more than the degree of the denominator, you do have a slant asymptote. Before we do our synthetic division, though, we need to figure out what number, or in this case, numbers, make the denominator 0. You can factor it as x minus 3, x plus 2. And then when you solve each set of parentheses for x, you get x equals 3, x equals negative 2. Those are the numbers we are going to use in our half boxes, so we are going to have to do synthetic division twice. Let's start with 3. We then write the coefficients of the numerator along the top row. Cubed is the highest exponent. Its coefficient is 1. There is no squared term, so we need to account for it using something called a gap filler with a 0. The x term is negative 5. And then the constant or plane number is 6. Now let's do our synthetic division. Bring down the 1, multiply it by the 3, add straight down, multiply that 3 by the number in the half box, add straight down, multiply the 4 by the half box, and add straight down. Now, the interesting thing here in this green problem compared to the first problem is that we are going to have to do synthetic division twice. We ignore the last number in that row, and we are now going to put a 2 in the half box. Again, whatever makes the denominator 0 is what we are going to put in the half box, and that should actually be a negative 2. Leave a line for some numbers, bring down the 1, multiply by the half box, add straight down, multiply by the half box, add straight down. Again, we ignore the last number. This is our constant, and this is our x term. So the meaning of this row is y equals x plus 1. That is the equation of our slant or oblique asymptote. Now, what some of you may be wondering is, well, what if we do synthetic division in the opposite order? What if we start with the negative 2 and then do the 3? Will we end up with the same equation for our slant asymptote? Well, let's go ahead through the work and see what happens. 1, 0, negative 5, 6. Bring down the 1 times the half box, add straight down, times the half box, add straight down, times the half box, add straight down. We ignore that last number, and now we are going to use 3 with synthetic division. Bring down the first number, multiply by the half box, bring down the add straight down, multiply by the half box, add straight down, ignore the last number. This is our constant, this is our x term. So you see, regardless of the order in which we do our synthetic division, we end up with the same equation for our slant asymptote. Moving on to example 3, the degree of the numerator is 3. The degree of the denominator is 2. That's exactly one more. So there is a slant asymptote in this graph. To determine how you do the synthetic division, you look at what makes the denominator 0. Now, 0 makes the denominator 0. But what's interesting or different about this problem is, since it's squared, it's actually 0 twice. This is something called a double root. So we're going to have to do synthetic division twice, both times with the number 0, and that is how we are going to end up with our equation for the slant asymptote. Since it's the same number twice, the order in which we do it does not matter. -1, 3, -3, 1. And again, the way we come up with that is you're going to have to FOIL twice. Do 1 minus x times 1 minus x. That's 1 minus x squared. And then you're going to have to multiply by 1 minus x again. And that is how we get the numbers in the top row. Leave a space. -1 times the half box, add straight down, times the half box, add straight down, times the half box, add straight down. Ignore this number. And now we are going to do synthetic division again with 0. Bring down the first number, multiply by the half box, add down, multiply by the half box, add straight down. Ignore that last number. This is our constant, this is our x term. So the meaning of that bottom row is y equals -x plus 3, which is the equation of the slant asymptote for that problem. Moving on to example 4, we have f of x equals x squared minus 2x plus 1 all over x. Probably a good idea to factor the numerator. That's x minus 1 times x minus 1. Denominator stays as is. There is nothing that we can cross out or simplify, which means there are no holes or removable discontinuities. Let's look at now what makes the denominator 0. Well, 0 makes the denominator 0, so that is our vertical asymptote. Again, it's a vertical line, so make sure you write it as x equals. To graph x equals 0, it is a line over the y-axis with the arrowheads. Horizontal asymptote. Well, the degree of the numerator is greater than the degree of the denominator, so that means there is no horizontal asymptote. There is, however, a slant asymptote. Because the degree of the numerator is 1 greater than the degree of the denominator, we do have a slant asymptote. 0 makes the denominator 0, so that's what goes in the half box. The coefficients of the numerator, 1, -2, 1. Do our synthetic division, bring down the 1, multiply by the half box, add straight down, multiply by the half box, add straight down. Ignore this last number. And the equation of our slant asymptote is y equals x minus 2. X-intercept, plug 0 in for y. Turns out to be 1, 0. Y-intercept, since we have a vertical asymptote along the y-axis, there's no way we can have a point on the y-axis, so that means there is no y-intercept. So let's go ahead and graph it. Y equals x minus 2 looks approximately like this. And again, make sure you plug this into your calculator and graph it so you get a better sense of what the branches look like. Okay. Okay, don't forget, x-intercept is 1, 0. There is no y-intercept, so the graph looks approximately like that. Moving on to example 5, we should start by factoring the numerator and the denominator. So the numerator factored is something called the difference of cubes. So that turns into x minus 2 times x squared plus 2x plus 4. Denominator is difference of squares. So that turns into x plus 2 times x minus 2. You notice you can cancel out or cross out or simplify the x minus 2 expressions. So that automatically tells us that we have a whole. The x-coordinate of that whole is whatever makes that 0, which is 2. To calculate the y-coordinate of that whole, we should probably rewrite the fraction simplified, x squared plus 2x plus 4 over x plus 2. When we substitute this 2 into that simplified fraction, we get 3 for the y-coordinate of the whole. Once we do that, we still look at the denominator to see if there's anything that makes that denominator 0. That is a vertical asymptote. Negative 2 makes the denominator 0, so x equals negative 2 is the vertical asymptote. There is no horizontal asymptote. Again, the degree of the numerator is greater than the degree of the denominator, so there is none. But there is, however, a slant asymptote because the degree of the numerator is 1 greater than the degree of the denominator. To calculate the equation of that slant asymptote, we look at our simplified fraction. Negative 2 makes that expression 0. And then we look to the numerator, the coefficients 1, 2, 4. Do our synthetic division. Bring down the 1, multiply by the half box, add straight down. Multiply by the half box, add straight down. We ignore this number. This is our constant. This is our x term. So the equation of the slant asymptote is y equals x. For the x-intercept, there is none. And the y-intercept is 0, 2. Now let's go ahead and graph everything. So we have a vertical asymptote at x equals negative 2, which we'll say is approximately here. We do not have a horizontal asymptote. We do, however, have a slant asymptote at y equals x, which is approximately here. We do not have an x-intercept, and our y-intercept is at 0, 2, which is about here. So the graph, and again, put it into your calculator so you get a good sense of what it looks like. Looks approximately like that. So that is it for the problems that we are going to be doing together. You still have 4 more problems to do in the practice problems. Please work on them and refer to the answer key to the skeleton notes for all the solutions. Make sure you also answer the question in the exit ticket, and you can discuss it with your teacher at the end of class.